Basic Statistics. Introduction. Why statistics matters in a corporate world. Think about it. How does your company decide on key performance indicators, KPIs, customer satisfaction scores, or agent productivity? All of this is driven by data. Whether you're analyzing call center efficiency, monitoring customer feedback, or forecasting business trends, statistics plays a crucial role. Today, we'll break down the key statistical concepts that help us make smarter business decisions. Agenda. By the end of this session, you'll walk away with practical knowledge to apply in your role. Here's what we'll cover. 1. Overview of statistics. How data helps in decision-making and business improvement. 2. Measures of central tendency. Finding the typical value using mean, median, and mode. 3. Mean versus median in business. Why the average can sometimes mislead you. 4. Measures of spread. Finding the typical value using mean, median, and mode. 5. Real-world applications. How statistics help in performance analysis, quality control, and decision-making in BPOs and corporate environments. Overview of statistics. Statistics. Today, statistics is utilized everywhere. We look at numbers, data, and with the help of these numbers, we understand the current performance of business, governance, organization. It is an integral part of any organization's day-to-day activities, and hence, it is imperative for us to understand what do the values represent and signify. Being Six Sigma professionals, data and numbers are of extreme importance for us. And to understand these numbers, we must be aware of basic fundamentals of statistics. Under this topic, we will understand different values that are used to represent the behavior of data, and hence we'll understand how these are used to represent the data. Basic statistics, central tendency, mean median mode, variation range, quartiles, interquartile, range stability factor, variance, standard deviation. Central tendency, mean. Mean of the data is also referred as the arithmetic average. It is calculated by adding all the data points and dividing the sum by the number of data points. Mean equals the sum of all the data points. Numbers of data points. Mean is equal to 1 divided by n times the sum of x sub ei, from I equals 1 to n. Mean. Example. Let's say we have a data set wherein the values are 2, 4, 6, 8, 10. To calculate the mean, we will need to add these values. The sum would be 30, and number of data points is 5. For mean, we need to divide the sum of values by the number of data points, and hence the mean here would be 6. Mean is equal to 2 plus 4 plus 6 plus 8 plus 10 divided by 5. Mean equals 30 divided by 5 equals 6. Sample mean is represented by x bar, x. Population mean is represented by mu, mean. Properties of mean. Mean of the data is also referred as the arithmetic average. It is calculated by adding all the data points and dividing the sum by the number of data points. It is sensitive to variation. It is used when we need a measure of central tendency that should reflect the total of the scores. It is also used to calculate some values of variation. It varies a little from sample to sample. Mean enjoys participation from all data points. It is influenced by every data value. Extreme values influence mean. Median. Median is the central point of the data. It divides the data in two equal parts, post-ranking the data in ascending or descending order. Median is the central point of the data. It divides the data in two equal parts, post-ranking the data in ascending or descending order. To calculate the median, we first need to arrange the data in ascending or descending order, and the central value becomes the median. And that's why it is also referred to as the positional average. It is the middle value when the data is arranged in the order of magnitude of the data points. After arranging the data in amending order, if number of data points is ODD, central data points becomes the median. If number of data points is even. Average of two central values is median. Median is equal to n plus first divided by 2, data point. Median example continued. Taking the same data set that we took while calculating the mean, 2, 4, 6, 8, 10. We first need to arrange the data in ascending or descending order. Here, the number of data points is ODD. Hence, post-arranging them in ascending order, the central point is 6. So, 6 is the median here. Here, the number of data points is ODD. Hence, post-arranging them in ascending order, the central point is 6. So, 6 is the median here. Moving ahead with the same example, let's add one more data point to make the total number of data points even, and then calculating the median. Here, the number of data points is even. Hence, post-arranging them in ascending order, there will be two central values, 6 and 8 respectively, and their central value would be the median, which is 7 here. Using the formula, here n equals 6, so n plus 1, e.i.e., 6 plus 1 would be 7, and dividing it by 2 will give the result as 3.5 e.e. After the data is arranged is ascending or descending order. The third 0.5 data point will be the median, which is 7 in our example. Median. Sample median is represented by x tilde, x tilde. Population. Median is represented by ETA, ETA. Properties of median. Median is a positional value, so is independent of the magnitude of data points. It is not affected by the variation in the data. It is the best measure of central tendency when the data is skewed, as is not affected by the extreme values. Median does not represent all data points, but represents a central location of the data array. Hence, the median is not biased by extreme values in the data set. Central tendency. Mode. Mode. Mode is the data point that has the maximum frequency, number of occurrences in any data set. A data can be unimodal, bimodal, or multimodal, i.e., a data can have more than one modes. Here, 8 has maximum number of occurrences. That means 8 is the mode of this data. Hence, this data is unimodal, having a single mode. Here, 4 and 8 have appeared 2 times each. Hence, both of them are the modes for this data. Hence, this data is bimodal, having 2 modes. Here, 4.6 and 8 have appeared 2 times each. Hence, all 3 are the modes for this data. Hence, this data is multimodal, having more than 2 modes. Central tendency, mean versus median. The decision of whether to use mean or median as the measure of central tendency is based on the variation in the data. If there is high variation between the data point, if there are extreme values, in that case, median is the preferred measure of central tendency, whereas in case the variation is normal, we can use either mean or median as the measure of the central tendency. As in this case, mean and median are approximately equal. Let's understand the above using an example. 100, 100, 100, 100, 100, spwanikenin, 100. Median equals 100. Say there is a group of 5 friends who have their daily salary as 100 USD. In this case, both the mean and median are same. 100, 100, 100, 100, 100, 100,000 mean equals 16,750. Median equals 100. Now, Let's assume we are joined by another friend who has his daily salary as 100,000 USD. In this case, we can see mean has shifted towards the highest variation, whereas median is still the same. That clarifies that as the variation between the data points increases, mean shifts towards that variation, where median is still the same. The above example clearly explains that the mean is highly sensitive to variation, and as the variation increases, mean shifts towards that variation, whereas median, being a positional value, is not affected by variation. Note: when there is high variation in the data, always go by median, which is considered to be more robust as compared to mean.